Greetings everyone, this is Jyoti Dodia. Welcome to today's PowerVC session. This is the 96th session in the PowerVC series, Virtual User Group Technical Webinar Series. And today's session is going to be about Ansible on IBM Power Systems and also PowerVC updates. I've got Stu Cunliffe on the line, ready to go, and he's also joined by a colleague of his called Rich Jeffries, and Rich will be taking some answering some questions in the chat window. So look out for those names, and without further ado, over to you, Stu.
Yes, thank you, Jyoti. Yes, good afternoon, morning, evening. Glenn Robertson is requesting. Right, Glenn, just going to deny that request. So yeah, my name is Stuart Cunliffe. I work for Systems Lab Services based in the UK. We cover everything power. Hopefully I've worked with a number of you in the past. And what I'm going to talk to you today about is Ansible automation around IBM Power. And towards the end, we're going to give you some PowerVC updates. If there's more information needed around the PowerVC updates, because it's quite a lot to cram into an hour and a half, I'm sure Jyoti will happily organise a PowerVC dedicated session later on in the year, should we need to. As Jyoti mentioned, Rich Jeffries, who's one of my colleagues who does a lot of work in Ansible as well, is on the call to answer questions because I can't see them pop up when I'm in presentation mode. So hopefully Rich will be able to answer them. If not, we can either try and answer them at the end when I'm off presentation mode, or we can contact you. You send them, we can contact you off after the presentation is completed. So I hope everybody's well. I'm in my, well, I say started as my office and then turned into a shared storeroom at the top of my garden, a wooden cabinet. It's roasted hot up here today. So I've opened the windows and the doors. If it does get too loud because I've got a lot of birds in the garden, please try and let me know or let Jyoti know, and I'll try and close the doors and bake quietly. So, okay, so let's crack on. This is what I want to cover today. So I'm going to talk about Ansible, what Ansible is, what the architecture is, differences between the engine and the tower and the nodes. I'm going to go through a lot of terminology. Now, Ansible's a very, let's say, there's a lot of elements to Ansible. We're going to cover what we can cover today, hopefully enough to be able to give you guys enough to start with Ansible if you haven't already. For those who have started, maybe to give you a little bit of feedback about what more you can do to get your Ansible configuration up and running. I'm going to talk about the key elements around modules, playbooks, roles, inventory. We're going to show you how we can provision LPARs via PowerVC in Ansible, so Ansible driving other products that IBM have, PowerVC in this case. We're going to show you some playbooks and some more advanced playbooks as well, and then we're going to do a bit about Ansible Tower if we get time. And then we're going to cover PowerVC updates. If there is anything you need to speak to me about, I've got my details throughout the deck. I've an email address, my Twitter and Slack, and on LinkedIn as well. So, okay, let's crack on. Hopefully that's what you expected to cover. I might not cover them in that order. It depends how I feel, but let's see what happens. So what is Ansible? So long and short of it, Ansible is an open source automation tool. That's what it aims to do. That's what it does, and it does it very well. We can use it for things like we've listed there, like provisioning, system configuration, and patching of servers, more detailed, more complex stuff like orchestration. I'll touch on briefly. Oh, train's going past. Let me just shut the window. And those areas that we're going to cover around the more complex orchestration side of things. So it's a fairly recent product. I think the work was started on it 2012, 2013 maybe, and then it was acquired by Red Hat in 2015. And we've been doing a lot of DevOps engagements over the last 4 or 5 years, and the popularity of Ansible has grown incredibly. It was something that we maybe 1 out of 4 DevOps engagements was. Now we're seeing it sort of 3 or 4 out of 5 sort of thing. So we're seeing the increased popularity all the time. the problem it's trying to address is this is around automation. Automation has been around for a long time. There are various automation techniques available. People are automating. Various silos within departments and companies are automating. People are using different automation tools. One of the things we found increasingly over the last few years that when we go to speak to a customer about PowerVM or Power Automation, they have a Ansible automation team somewhere else running maybe their Linux estate or working somewhere across one of their networking type of areas. So trying to bring that all together is what we're key to, making sure that Power is part of your Ansible automation strategy. So it's not just about the process of active automation, it's about the fact that we can it's a product that allows us to share projects, allows us to share skills, and it's a very, very easy to use product. Hopefully I'll show you that today. So if we look at what products there are out there, now I'm not going to go through each of these individually, you'll be pleased to know, but we've got a whole spectrum. I'm sure there's a lot more on this list now than there was when I took this a few months ago. We've got stuff on the left-hand side from source control management all the way through to database and water management, integration. And from the right-hand side, we've got the cloud, we've got IOPS, we've got release management, and obviously sort of the containerization side of things now. But where Ansible sits is right in the middle of a blue section, that configuration section. So talking about products like Chef and Puppet and Terraform, SaltStack, we've all used these across various Power engagements. Terraform is coming into the front an awful lot more at the moment, but I'm seeing a huge increase in people wanting to work with Ansible. The stuff we're going to talk about today is mainly the Ansible engine. I'll explain the difference between that in a minute, but the Ansible engine is where the core of Ansible. We have the tower on top of it, which allows scale. Then we have the software as a service element that Red Hat and a few other people offer. But the core stuff we're going to talk about today are the bottom two areas. Hopefully that's what you expect. So what is Ansible? Okay, so key points to remember about Ansible. Ansible engine, or Ansible controller, some people call it, runs on Linux. It runs mainly on RHEL or Ubuntu, obviously other. It is open source, so we are able to run it on other flavors of Linux. The engine manages a large number of clients, as you'd expect. These clients are what we define within an inventory, and I'll discuss inventory in a little while. We do not require an agent on the client. It connects using SSH and runs what we're going to talk about later, modules with it, about using Python on the client. So there's no endpoint agent on the clients. But these clients can be virtually anything we can think of. AIX, IBM, RHEL, other flavors of Linux. They can be network stitches, storage controllers. The list is intense. So we can look at this list and we can see a lot of reason why people are going down the Ansible route. In fact, it's a single point of automation across multiple devices. One of the good things about Ansible is that the configuration, the automation we can see, which I'll talk about in a bit, is human readable. We can look at a playbook and we can see what that playbook is trying to establish on the client. You don't need any special coding skills unless you want to write your own modules, which I'll talk about in a bit. And these modules will actually perform their tasks. We can call a module to run against the client by the command line or playbooks, and we'll discuss playbooks today. The idempotency is key, and I'll go back into this later because this is one of the key elements around Ansible, and I need to explain to you a little bit about what the idempotency is. And it is very simple to get started. I think if you've got access to a Linux LPAR, VM, whatever, you could have this fired up and running and talking to your clients within an hour just to do simple testing. So very simple. So the architecture. This is what we're going to delve into. The key elements. As I said, there's a lot more available to here, but we're going to talk about the engine itself. So the controller, the inventory that it controls, the modules that it calls, the playbooks that call those modules, and then the client hosts, the endpoints that we connect to. And we're going to start with the inventory and the configuration file. Okay, so the inventory file is a configurable list of VMs and Ansible controls. So a bit like your etc host on a Linux box, it's a list of servers that you want Ansible to communicate with. So it's written in INI format or YAML format, and it lists hosts and groups. It can be static or dynamic. I think say or, sorry, not dynamic, static or dynamic. So a simple inventory file that I've shown before, this is a static inventory example. The default is etc Ansible hosts, and in the square brackets, we've defined a group. So here I've got two groups. I've got rel dev and I've got AX dev. And within each of those groups, I list the clients. So simply a host name, a resolvable host name, or DNS or locally resolvable, it's the client name. So I've got two rel servers there, and I've got two AIX servers there. We can collect those groups together. So at the bottom, you'll see that I've created another square bracket group called dev and defined its children as rel dev and AX dev. So when I look at dev, it's going to list all four LPARs as its members because we've combined two different groups there. A simple way to look at what is in your inventory is to run the Ansible-inventory program. We can call it a couple of ways. In this example, I've shown a graph, and it shows me in a tree format. It shows me I've got a group called dev, I've got a group called xdev with two members, and I've got a group called rel dev with two members. And obviously, dev is the master group collection of both those groups. Within the inventory file, as well as define the host, we can also define client unique variables. So in this example, I've just expanded a bit more. I said for lab rel1, when you connect, I want your Ansible user to be Ansible. So by default, the user that Ansible connects by is a root. If you want it to connect by another user, you can define it in this file. You can define it in the variables file within Ansible. But what it allows you to do is connect via a maybe non-authoritative user. If you need to run something that's authoritative, we give it an option of being able to run it to promote its user ID to root, for example, using an su-do type example. The next example I've got, as I said, I want you to listen. My Ansible port is port 222. I mean, obviously, Ansible listens on SSH, so the port is normally 22. But if you wanted to define it, it's just an example. And then for the rel one, I've listed there that instead of using the IP that you resolve lab AX1 to, I want you to use this IP to resolve that host to. So you can define multiple variables within the inventory file. If we run the Ansible inventory with the list option, it can show those variable options. So there we go. It just says host variables and those ones that I've defined in the inventory file. Okay. We can also define group variables. So I defined AX dev as two hosts. Then at the bottom, I said AX dev variables, and I've defined a proxy setting for my AIX dev LPARs. If I then check it later on, I can check the inventory, and I can see the fact that that is set as a variable, proxy variable is set. Now this is dynamic. This goes and reads the inventory file every time you run the Ansible command against it. Now, one of the advantages I find with the inventory is I actually use my dynamic inventory quite a lot because a lot of the VMs I deploy that we test, I deploy via PowerVC. So I ask PowerVC to go away and build me an LPAR. I don't really know, well, I might define the host name, but I might not know what IP address it's going to come back on. I don't want to then have to update my static inventory file. So what you can do is you can use a dynamic inventory file pointed at your on-prem cloud, your public cloud. So here, example, I've done an Ansible inventory, and I've told it to use my inventory file openstack.yaml, and it's gone away and discovered all my clients that are running on my PowerVC server. So obviously a lot more, but it's a very good way. So if I build, which we'll show you in a little bit, if I build a VM in PowerVC and I'm using my dynamic inventory, straight away, that host that I've just built is now part of my Ansible inventory, and I can start running commands on it. I can start configuring it. I can start using it as a normal Ansible client. Now, one of the questions I get asked quite a lot is how many inventory files should I have? Should I have one inventory file for each environment, or should I have one shared inventory file that breaks it down into maybe prod group and staging group and dev group? We can define multiple inventory files if you want to. So if you use the -i flag on the command line with Ansible, you can point to multiple inventory files should you need to. You can set the Ansible inventory environment variable. You can use the inventory equals in the Ansible configuration file, and all else fails, it will look in the default, which is etc Ansible host. And I've just shown a little bit a method at the bottom there where we can show what inventory file is. Now, this is key because if you're using the wrong inventory file and you've got a playbook that is set to run against all the hosts in that inventory, you could be running a, I don't know, maybe a dev upgrade on your production environment. So make sure you know which inventory file it is. This is why I've shown you the precedence order here of what Ansible will look for. So maybe use the -i flag as much as you can, but again, keep checking on which inventory file you're using. The configuration file for Ansible is a configuration that determines a lot of parameters. There's most of the parameters that we can define can be overwritten in playbooks, but there is a list of default parameters. There's hundreds of them, but the default is etc Ansible, Ansible.cfg, and I've just cut an example there that I've used. Now, one of the defaults within Ansible.cfg is the inventory line, which you can see at the top there. Now, again, if your Ansible.cfg file is calling the wrong inventory file, you can get yourself into a whole host of bother there, calling the wrong clients that you're going to communicate with. Again, there's precedence order for your Ansible configuration file. It will use the Ansible configuration environment variable first. It will look in the current directory if there isn't a variable set. It will then look in your home directory for Ansible.cfg, and if it can't find anything there, it will look in etc Ansible, Ansible.cfg. You can find it quite simply by doing an Ansible -- version, and it will tell you which configuration file you're using. The configuration file, I said there's over 190 configuration parameters that we can put in there. If we do an Ansible config dump, it tells us all the Ansible settings that we've got. As I said, there's already 190 plus in there, so it's not really that useful output. But what you can do is you can do an Ansible config dump only changed. So if you haven't got an Ansible.cfg file configured, Ansible has a set of predefined variables that it uses. If you've deviated from any of those and you do an Ansible config dump only changed, it will tell you what you've changed. So it's quite handy to look to see that, okay, I've changed maybe my inventory file, I've changed my my callback plugin or something like that if you're having issues around your Ansible. And I put a note at the bottom. We need to make sure as often as we can that we're using the right configuration files and inventory files. I've seen customers, unfortunately, call the wrong playbooks against the wrong inventories and got themselves into a little bit of a mess. But it's very easy to keep track of, control of if you want to. So modules. So this is where we're going to get interested now. Now, modules are the core of what Ansible is. So with a module, they perform the work by actually executing on the client. So what Ansible doesn't do, it doesn't execute the module locally and send it on the engine and send it across the client. It actually connects the client, pushes the module over with the parameters you defined, executes that Python module on the client, and then removes the module from that client. If you're on the client and you've run something from your Ansible engine, and maybe it's a long-running job, if you check the PS and you can see the output, you can see that command running. You can see the temporary file that's being copied over. So it's hidden, but you can see it. So Ansible comes with a lot of modules. There's thousands and thousands of modules. I'll show you some of those in a little bit. They cover lots of different areas. As I said, they're storage, files, server, network, database. And these are written in a, so anything that returns a JSON format, they tend to be written in Python. You can write your own modules if you want, and one of my colleagues in the US has written quite a few. He's taken some of the ones that we'll be looking at later and rewritten. In fact, Rich on the call has written taken some of the NIM modules and rewritten them for our own use. So they are Python. If you've got a bit of Python experience, you can copy them, you can edit them, and you can place them into your own module library. The syntax to call a module from the command line is very simple. It's Ansible. That it's -m for the module name, and -a in any attributes if you want to pass it any attributes. And then we're going to talk about this idempotency again. I'm sorry, I'm not even sure I'm pronouncing that correctly, but that's how I pronounce it, idempotency. So it's a mathematical term, and it's one of the things that makes Ansible what it is. So the dictionary definition is denoting an element or a set which which is unchanged in value when multiplied or otherwise operated on itself. It doesn't really mean much to me, but in Ansible terms, it means that if you run a playbook and it sets things to desired state, further runs of that same playbook should result in 0 changes if nothing has changed. So idempotency means that we can be sure of a consistent state in our environment. So one of the things we're trying to get away from here is configuration drift. So if a VM, an LPAR has been deployed and you configure it a certain way, then over a week somebody's tweaked something, somebody's changed something, that configuration is different from what you think the configuration is, different from the configuration of maybe it's partner HTTP server or partner PowerHA server. So what Ansible will do is it will change those values back to the values that you required in your initial call. The one that hasn't changed, it will just say, oh, nothing's changed, I'm going to skip that, skip that, skip that, everything's fine. It'll notice changes that have been made and it will prevent configuration drift. We'll show you some examples. So I'm going to call here a module. So Ansible, and then the name of the VM I want to call again. So I'm going to call it against an individual VM here, so lab AX1. The module I want to call is AIX_LVOL, and I'll talk about where these modules are in a little bit. And I want to pass it some parameters. I want to say my LV name is testlv, it's 10 meg, and I want you to put it on root VG. Okay. So when I run that command, Ansible goes away and it says, do I need to make a change? Now, I haven't specified in there that it has to be present. The default for AIX logical volume module is present. So basically it says, I want to create this logical volume if it doesn't exist. So you'll see the first time I run it, it says change lab AX1. So it's gone and created that logical volume for me. If I ran that again, straight after, Ansible recognizes, that module recognizes that it already exists. The idempotency is kicked into place. It says, well, you've asked me to create a logical volume called testlv at this size on this volume group. That already exists. So I'm just going to say, okay, and skip it effectively. You'll see there's 0 change. If I change the size, that's a different matter because obviously it doesn't match what I've asked it to do in the Ansible configuration or these variables that I'm passing to it at the time. So talking modules, here we go. So this is a list. So here's a link to the modules within the Ansible documentation. So I'm going to quick look on that. Make that a bit big. It's probably a bit small on your screen. So these are all the modules that are available when you download Ansible, install Ansible on your controller. As I said, there is absolutely loads of them. So you can use some of these. You can look through which ones are relevant to you. If you look in, say, system, you'll know that we've got some AX specific modules here. So we've got ones for devices, file systems, init tab, volume groups. What else? We've got a makesysd one here. We've got a few other little ones as well. So a lot of them are generic to certain types of operating systems. So I will come back to these in a little while, but if we just look at one for now, let's click on AX devices. So it tells you the devices, it tells you a little bit of information about them, the parameters, it gives you some examples. Now these examples are obviously playbook examples, but those attributes that I ran from the command line can be used still, and I'll show you how we run them from the playbook in a little bit. So there's a lot of modules out there, and we'll talk about AIX support modules in a little while. Okay, so let me come back to my presentation. So some modules are very generic. Right? There's a ping module, for example, which will connect to the host and verify a user. It doesn't use ICMP ping, to be fair, but it's a trivial module test. It basically returns Pong if it can communicate or fails if it can't. Some of the modules are specific to OS types, like Linux types. So we've got systemd module, which will manage services, but obviously that uses a system CTL, so it wouldn't work on maybe AIX. And then we've got other modules that are written specific OS distributions like AIX. And I've just shown you the AIX devices one, which uses commands underneath in the module like chdev, lsdev, which obviously wouldn't work on Red Hat. So as well as looking on the website to look at these modules, if you can use the Ansible doc command from your engine. So in this case, if we do Ansible doc AIX_LVOL, it shows the location of the actual Python module, should we want to look at that. And then it tells us all the options underneath, so the attributes that we can call. So there was LV, there was size, there was VG, and everything, but this indicates what options are available. The double equal sign means that is a mandatory. You have to give it an LV name if you create a logical volume. So it makes sense. At the top, we can see the AIX LVOL Python module that it calls. If we look at that, we can see what it should have. So it tells us information about the author. This was written by Alan. It tells us the name, a bit of a description, what it does. And then if we go down a little bit, we can see that the commands it's calling. So here we can see that one of the commands it's calling is mclv. So we can change this if we want to. We can copy it. We can recreate our own modules should we need to. If we called a module that was invalid, so simply if we called a Linux-specific module against AIX or an AIX Linux or an IBM i1 against Linux, we would see it fail. It will basically try and find executable that is in that module. So in this case, if I try to run it against, you'll see at the top left, I'm trying to run it against a RHEL server. Obviously, the AIX LVOL is AIX-specific, and it tells me further on down the line, well, I'm trying to run the lsvg command. Where's that? I can't find it. Well, of course not. It's not a RHEL command. So specific modules for AIX and IBM I. So there are quite a few out there. So you saw on the list there, we've got system modules, which are specific only for AIX, which are actually within the Ansible library. Okay, I think if I go back to this page, you'll see that at the top it says this module is maintained by the Ansible community. But they are within the Ansible library. You can also download your own modules from GitHub, for example. There's a number of NIM ones that I've got on the right-hand side. Those ones can be downloaded, placed into your module library on the engine, and then when you make a call, it will find them. These are the ones that, for example, I mentioned that Rich has changed, so we'll talk about those towards the end when I'm doing my demonstration. There's an awful lot of IBM I modules out there now, which have been written recently. So we've got ones that maybe display subsystem information. We can end a subsystem. What have we got there? We've got fetch. I think there's a fetch objects in the library. We've got install from Savef. So we've got where we can install programs from the save file. So there are a number of modules out there which are IBM specific. Now, in the past, these sorts of modules have been available. People can download them, use them at their own will. However, we've got a project that's due for release in June next month, where we are going to AIX modules are going to be supported as core modules. So we've got some there listed, like we've got NIM, we've got Sumo, we've got FLIRT, VC, Gen installation. The plan is as well, we're going to be using, so the ones we mentioned earlier, so the ones about AXL volume, file system, AX devices, they're all going to come into the support module too. So these are the things that we will be able to support moving forward, statement direction within support contracts with Red Hat and IBM. So all these modules that have been written over the last 4 or 5 years, which are specific to IBM I and AIX, which was best effort support and community support, are now hopefully going to start brought in. So the IBM has seen the value of power modules with Red Hat. So watch this space, and as soon as we get some more information about when and what's going to be supported, I'll let you guys know. What happens if there aren't OS-specific modules? Well, we don't have to worry about it. We've got a number of modules that we can run that allows us to execute commands or scripts or shells commands on our clients anyway. So if we look at those ones there, we've got command, for example, we've got script, we've got shell, we've got a raw, which is a raw command. So an example of this, so if we wanted something simple like cat and etc motd, we could run that module that way around. So we've got Ansible command -a cat motd, shows them the entries for the message of the day. So again, we just call the module command and we pass it the attributes. We can run a local script. So I've got a local script to Ansible engine called show date, just showing you what it's in it. I can then use the module with my script, pass it the actual script. It copies the script over and it runs it on the client. So we've got other ways of being able to do non-module specific commands. One of the key things that we can do within Ansible is to run the setup, which goes away and collects thousands of facts against a client. So we run the Ansible -m setup, it goes away and finds information about hardware, OS, all the information can be gathered, it can be reported on. If a module allows us to change it, we can change it. We can filter on these, which is key, and we can use them when we want to run them against the playbook. So for example, there I've shown the fact that my AIX server is running on PowerVC version 8, it's got a model name, it tells what OS family it's running from, so it knows it's AIX. So a very good way of getting information about the server. So let's have a quick demo on this. So where am I now? Let me just check I'm in the right direction, right directory. Okay. So first of all, one thing I want to do is I want to make sure that I'm using the right inventory file. So I run the command that I showed in my example before, and hopefully that comes back and says, yes, you're using this file. So let me cat that file. And there's a very, very simple inventory file that you saw earlier. No, nothing special in there, what we would expect. I can use the graph command, and it shows me that in a tree output. But if I change directory to another directory, sorry, and run it again, see suddenly I'm looking at a different set of clients. So if I was running a Ansible command against my inventory, just from changing directories, I'm suddenly targeting another set of clients. So I just wanted to make sure that you're aware that this is something that we need to make sure that we're keeping an eye on. Okay. So let me have a look. So we can see, let me just bring back up my clients again. So let's just run a simple module. Let's run a ping module against one of my clients. So I'm going to ping AIX dev, comes back straight away against a group of servers. So it's come back and pinged 2 of my servers. What happens if I want to ping everything that's in my group dev? You saw before, it's a collection, so it's come back against all 4. Or I can say run a module against an individual host. So I just want to run a ping module against my LabRel1 server. Okay. So very, very simple example of a module. If I wanted to have a look at documentation, so I'm running a Ansible doc file here. It tells me that this module is maintained by the core team. This is the file if I want to look at it. If I wanted to run something against an AIX specific module, let me have a look at, say, AIX devices. Again, it comes by the information this module discovers, defines, removes, and modifies attributes, and there's the location. And also the fact that it's maintained currently by the Ansible community. Okay, and the one I'm going to show you a little bit about now is the one that we just highlighted a minute ago, so the logical volume 1. So the logical volume 1, this module creates, removes, resizes the logic volumes, and it's inspired by the LVOL. So I think, I forgot who said it was, who created this one now. They've obviously taken the LVOL one and changed it from Linux-specific logical volume commands to AIX-specific volume commands. And it's been included in the Ansible library, so you've done a good job. Right, okay, so let's call something from this module now, from the command line. I want to do the option you saw earlier. So I want to create a logical volume that's 64 meg on root VG. Go away and run it on that single host, AIX, lab AIX1. It's going to run it. We see it's changed. If I run it again, we should see, hopefully, that it won't change it. It's okay. It says I don't have to change that the second time around. Let's check that that's okay. I'm just going to change my callback so we get a bit more information. So I'm going to run a command. I just want to use a module command. I'm going to run lslv against that new module. And what have I done there? I didn't want to say lslv test. Oh, I just okay. And sure enough, it's gone and created it. If I decided, actually, no, as we said, this is this is the wrong size. We want to make sure that that logical volume is now 128 megs. Oh, I'm not missed at the end. That's not going to work. Let me go back in there and put the M for them. We should see a change. So I've changed the output a little bit so you can see what it's doing. So it's actually changed it and it's extended it. If I bring up the logical volume list again, I should see now that, yeah, we've got 2 copies. Now, as I said earlier, the default is present. So in other words, things like AIX LVOL will make sure that that is present. If I wanted to say, actually, I want that state to be absent, not present, using that command, it will go and delete it. So that logical volume is now being removed from that client. So yeah, there's nothing there. Cannot find LSLV and cannot find test LV within the configuration, as you would expect. Okay. So I mentioned previously the fact that we can run the setup command to go away and get all the variables about the client. So let me just show you that. I'm going to run the module called setup against a single AIX LPAR. This could obviously be run against any type of OS. It's a default Ansible module. And look at all the information this brings back, not about devices, about IPs, about OS levels, about file sets that are installed. And we can use that to go away and get information such as OS family. So we can type what OS member is it? What OS is this client running? We obviously know from the host name that's running AIX. It tells me that it's an AIX server. So this is the core to be able to draw back information from our clients. Okay. So,
Stu, just to interrupt you very briefly, there have been a large number of questions in the chat window which Rich has been going through and answering. So there has been a large number, and if there are any kind of themes, maybe Rich will tell us towards the end of the session. Okay. So if you have got questions as participants, then post them into the chat window. Thank you.
No worries. So let's go through playbooks now. So we discussed the core modules at the core of Ansible, but playbooks are how we tend to drive the Ansible modules. So playbooks are the configuration, deployment, orchestration language. They give instructions on what we want our remote clients to look like. They're written in YAML format so we can read them. Now we have idea of basic ones, which can just do basic management configuration. We've got advanced playbooks where we can talk about orchestration and rolling updates and monitoring, that sort of thing. So we're going to talk about some playbooks now. So if I cat a playbook, so it's in YAML format, so here I've got the simple one that's just listed at the top there. In blue is the actual playbook. So from the triple lines down to the bottom is what we call the playbook. The playbook contains a play. So here we said name. The play is actually called create backup LV. And then we have a tasks within that play. So we have, you'll notice from the tab format, the one dash name is the play. And then from that point onwards, we have tasks, and we have multiple tasks within a play, within a playbook. And that's how we tend to work it. So we define the play, we get it a name, we tell whether we want to go away and gather facts, or do you want to go and run setup and collect the information, which host we want to run it again, the name of the tasks. Then underneath the name of the task, this is where we name the modules. So the information I've been talking about previously, where we're calling modules, this is where we call them within tasks. So we've got the AIX logical volume there, which is what we talked about, and then the parameters that we set, the attributes that we pass on the command line, we pass via this tab, the playbook entry. If we run the against that playbook, we can see pretty much what we saw from the command line. It's because we said that it's going to run across our AIX dev host. It's gone and changed both those servers at once now. it's going to change lab AX1 and lab AX2, and it gives you a recap at the end of the time. So I only had one task in this play, but we could have multiple tasks. And here's an example. So this is a playbook that we've got that has got 1, 2, 3, 4, 5. It's got about 8 or 9 different tasks in it, and we've listed them there. Now, when you run a playbook, you don't have to actually run it. What you can do at the top, I've done a list of tasks. So the list tasks doesn't actually run the playbook. It goes away and lists all the tasks that are included within that playbook, within that play. So here we see the plays called makes B and expect man client install, and all the tasks that we've listed down the bottom. Now I've left the tags blank for a reason. I'll show you that in a minute. So we can see what we're going to run. We don't have to just run it blindly. However, what we can do, and this is best practice really, we should include a tag after each task to identify what type of job that task within the playbook is going to run. So here I've listed, for that proof, I've listed just 3 of the tasks. One of them I've tagged saying install, one of them I've tagged saying install and copy, and the bottom one I've tagged saying file system and backup. So if we call the previous command before where we list tasks within a playbook, we can now see tags associated. Again, this hasn't run the playbook, it's just listing the tasks. And the tasks have also shown us what the tags are, so we can see in the right-hand side square brackets what their tags are. The reason we do this is that we can list just specific tags, and we can run just specific tags, which link to specific tasks. I don't tags and tasks, so it gets a bit tongue-tied. But we notice here that the third one down had a tag of copy. If we say list tags minus tag copy, it will only list the task that has a copy tag against it. Okay, which is fine if we're listing, but what it actually allows us to do, it allows us to just run that part of the playbook. So if I then ran the playbook, you'll notice in the second window, I'm actually not putting the task list task command in there. So I'm actually asking the playbook to run, but this time I'm saying only run the task copy. So it only runs that one task. So we can have a large playbook, but we don't have to run through it sequentially. We can pick tasks out should we need to. Again, one of the good ideas for best practice, we should always try and tag our tasks, and all our tasks should have meaningful names so we can see what they look like when we list tasks. So I want to talk briefly about variables. So within Playbook, we can define variables. So at the start of the Playbook, I've got a list here. So I said variables, I've got 4 variables listed, a source directory, target directory, a AX code, and rel code. Now, within the Playbook further down, within the task further down, I've got a copy task. We call the copy module, but I've got a source directory is the same on both modules, but the variables are different. One of them calls AX code and one of them calls rel code. So as you'd expect, you can define variables within a playbook. You can also define variables externally to a playbook. So here I've got an example in my playbook where I said I want you to include a variables file called AIX YAML. And then I want to run a command called, with the variable is OS check command. Now nowhere in this playbook have I defined OS check command as a variable. However, if I cat AIX.YAML file, it's in there. So my OS check command variable is OS level -s. So it would run that OS level -s in the original playbook, which is handy if you've got different commands for different operating systems. So if we looked in this playbook, for example, I want to run the OS check command against AX, Red Hat, Ubuntu, obviously more available. And I would have a variable file for each of those. So AX YAML would be AX, rel YAML would define what command I want to use to call the rel OS command. So we've covered playbooks briefly. I'll go into it in a bit more detail in the demo that I'm going to run in a bit. But roles are, again, a key element that we want to do. So it allows us to be able to repeat certain actions within a playbook. So rather than we can break down a playbook into various roles, those roles can then be reused to create other playbooks further on down the line. So they're a good practice. So we use the Ansible Galaxy initiate command to create a role. And what that does is creates this tree structure that I've shown. Now this tree structure obviously contains all its own YAML files. And if it's called and those YAML files have something in them, that section of the role gets run. Now, we can then take this role and we can run it against it, include it in a different playbook. So that role is a reusable piece of code. If we look at a complex playbook, so one of the reasons I wanted to show you this, if we look at a complex playbook, and this is the one that, so we've got a playbook that goes away and creates VMs across PowerVC. Now, we took a very basic OpenStack module and Rich defined it and created it and made it a very, very good playbook that allows us to do various things, which I will show you in the demonstration. So if I list the tasks in my VM build playbook, you can see I've taken about the 65 different tasks in this playbook. If that was a playbook doing the whole job, it would be the whole work from create to list. The playbook itself would be thousands and thousands of lines. But what we do is we break each task into individual roles. So, for example, here we've got VM network list on the left, VM image list, VM flavor, VM name, VM create. We've tagged them, and each of those is an individual role within the playbook. So, if we look in the playbook, we can see that we've got a task, say, list available networks, and what it does, it goes away and imports a role. That role is name network VM network list, and it goes and runs that. So, all the VM network listing commands are all contained in those 4 lines in the initial playbook. They're external in a role, which we can then reuse should we need to further on down the line. Okay, so what I'm going to do now, I'm going to run a demonstration. Now, I pre-recorded this demonstration, because I think the kids are on Netflix and we always lose net connectivity, and I just wanted to be able to talk through it at the same time. So what we're going to do now, we're going to show you some complex playbooks, and we're going to show you how it works. So on the left-hand side is my Tower server, my Ansible server, sorry. Of course, it's got Tower as well. On the right-hand side, I've got my PowerVC, and then I've got my HMC at the bottom. So I'm going to check that I'm using the Ansible configuration file. Now, my inventory file, you'll see, is set to OpenStack. So I'm using a dynamic inventory here. It's going away to my PowerVC using a plugin called OpenStack and actually going and get my clients. Just going to source my file to make sure I'm using the right PowerVC server, and then I'm going to show you what is in my current inventory. So this is going away, talking to PowerVC, talking to OpenStack. This could obviously be your environment within the cloud if you've got one. So this doesn't have to be your on-premise private cloud. This could be public. And it's going away, and it brings back all my my VMs. It places them into certain groups that PowerVC seems to pass it back, where the original host name was, good serial number, obviously because there's pinning and soft pinning in PowerVC, and then all the instance names here that we can see. So I've got a test rel 8 server in there, and the instance ID, and then like my default OpenStack region 1 group. So I've got all those current clients. If I wanted to ping a group, I've chosen a group there, and I'm going to just go away and try and do a ping. And what that will do is, I can't remember how many clients are in that group, but I just want to make sure that I can communicate with my PowerVC successfully. So I've got my rel 8 test server was actually in there, my DNS2 server's in there, and my LDAP server was in that group as well. That's fine. Okay, so let's have a look at this playbook that I mentioned. So my VM build playbook, so it's fairly complex. However, because it's all in roles, it looks a little bit easier. So we have our location. We've got some prompts in there that Rich has put in and basically prompt me for. So here we go. So we list the networks. We list pick a network. So these are all roles here. So import role is my module. So it's going away and importing the role. So we've got the image list there. So let's have a look at my roles directory. And then we can see my VM network list. Sorry, I'm going to be the one to use. So if we look at VM network list, the role in there, we can see that there's a number of YAML files created within the VM network list that we could call. So if we wanted to use the VM network list in another playbook, not just one that did a VM build, we could use it. But this is where all the complexity is for these playbooks. They're actually within the roles subdirectory and the roles defined that we've got here. So here we see what it's actually going to call now. So it's actually going to call the OS Network Info module. So OS is an OpenStack module. So if I do a documentation on that module, we can see what it tells me. It tells me where the module is, if we wanted to look at the Python script, and it tells us a bit of information about it and the variables that we need to call. So this is actually the module that's going to go away and do the work. Obviously not the network one, but the OS, the OpenStack create one further on down will actually go away and build it for me. I've not written my own modules to go away and connect to PowerVC. These are all available in the PowerVC library. So if we look at the playbook that we were talking about, the VM build playbook, just list the tasks that are in. Okay, we'll list the tags first. So what have we tagged the various tasks as? We should see all the high-level options are available. So we've got a VM create, VM flavor, so images, list, and networks. If we list the tasks, we can see all the different tasks that this playbook will call in the order that they will call them in, and the tags that are listed. So we could call part of a playbook if we wanted to. Everyone's got VM create tagged against it, but some have got VM list, VM images. So let's say we wanted to just look at the VM list tasks within a playbook. We can just do the list task minus tag VM list, and what that should show is just the tasks that we would call if we just called that. So yeah, a smaller subsection. So it's basically going away and retrieve list of VMs and debugs and others output that list of VMs that are shown on my PowerVC server. So let's take out the list task and actually let's run it. Let's just run all the tasks in that playbook. They're tagged with VM list. So this is something we could call. So VM list, for example, might be something we want to call if you want to check OS levels. We don't want to run the whole VM create command, but we might want to go away and check what VMs exist on our PowerVC environment. And this should return us a list of VMs. There we go. So all the VMs, and we've got the active state as well, whether it's stopped or active as well. So let's actually run the whole playbook now. Let's go and run a playbook. Let's remove any tags. Well, okay, we have got a tag that calls all tasks. So we've got a VM create tag in there. So let's go and execute this. So what this is doing now, it's going to run that whole list of tasks we saw before. I think there was 65 of them in order, and it's going to prompt us for some information. So we set the playbook for a prompt. So I was nearly typed there, but this is the video. So we've called it VUG demo. It lists the VLANs that's displayed. So we pick a VLAN for it. I'm going to put it on VLAN 156. Let's go away and just looks at the images distribution we've got. So we said, okay, this one we want to be AIX, we could be IBM I, and it goes away and lists the image flavors we got, the image names we got that are AIX specific. Obviously, this could be I, it could be Sled, it could be Red Hat. It says, okay, you picked that image. Now I'm going to look at flavors, so now compute templates. I'm going to pick a medium compute template, and I'm going to go away now and check against my list of current VMs that you don't have a VUG demo LPAR, and make sure that that's valid, and it comes back with information. There you go. So I'm going to create a new VM called VUG demo, VLAN 156. Do you want me to go ahead? So it's picked all the information. So we should see, I don't want to say should, this is a video, I know it does. On our PowerVC server, we will see the VUG demo getting created. And then on our HMC, we will see the HMC show the information too. And at this point, I think I've cut about a minute out of the video because obviously my PowerVC server takes about a minute to be able to build the VM and boot it. So you'll see on the left-hand side, there you you go, there's the UG demo arrive on HMC. On the left-hand side, it waits for the instance to be created, and then the next step, once it's been created and had feedback from OpenStack that's been created, it will try and SSH to it. Once it's SSH to it, it will copy the key, the public key over of the Ansible server to the client, so it's now a valid client. It's waiting for the SSH port to open. Don't think this takes too long. I think I cut enough out of the video for it not to be something where we have to twiddle our thumbs. Yeah, just checking that the name's right. And there we go. So it's now created it, connected to it, and copied the key across. There are plans for modules to be created, by the way, for VIOS and HMC. Just in case anybody was thinking about modules, not just AIX and IBM specific. The statement direction is to have modules for HMCs potentially, definitely VIOS. So obviously we've got issues there around how we're going to do that, but that's the statement direction. So now if I show the inventory again, remember this is the dynamic inventory. So let's go away and query my PowerVC server. And there we can see my VUG demo is get built. Now, the point of automation, deployment and configuration is what we're trying to do, what I'm trying to do is in my image that I'm building my LPARs VMs from, I try and keep it as vanilla as possible with just the basic information that I need that is never going to change. What we need to be able to do is once that VM's been built, we need to be able to run a playbook against it, a playbook which does the configuration that we want. So in this example, I'm just showing you a df command. My basic image installation that PowerVC installed is got standard size file systems, nothing special on there. The reason we do that is that when we want to configure a VM or a server, an LPAR, we can run a playbook post deployment. So we can build a playbook against it, which we could easily change. So we want our configuration to change. So I'm showing an example here, the setup AIX VM. And what it does is it does things like it checks a certain directory exists using the stat module. It creates a directory using the file module if it's not there. It copies a file across using the copy. It uses the AXLV to create a logical volume. I'm sure I'm going to page down in a minute. It does things like it creates makes it be. I think I might have taken that out of this example. That's why I just paused and then I can't remember whether I did it. It certainly creates a file system. Obviously, we're creating a logical volume. Oh yeah, it does an install P. At the bottom, you can see there an install P. So it copies a very simple LPP across and then does an install P from that directory. So it makes sure it installs it all. So if I wanted to make change, so for example, I wanted my file system to be different sizes or my LPPs to be different or my modules to be different, I don't want to be cutting my PowerVC image every time that I'm doing this. So what I want to do is, as I say, install a vanilla OS and then make all these changes. Then I can do one of two things. If I need to change an existing VM, I can just change the module and run it again. If I need to build a new VM, then I can build a new VM and still apply that default configuration so we don't get configuration drifts. So if I look at that setup AIX playbook, it tells me what it's going to do. I've tagged it, so best practices. So yeah, we create that as we should. Now, obviously, if I run that playbook, it will run that playbook against everything in the inventory. Now, I can limit it. I can just say I want to play that playbook just against my new VM. So if I run it against the new VM, I'm going to gather the facts that new VM. It's recognized that and it's go away and it's created the volume groups, logical volumes, the install P, the installed that file set as I expected. So it's now going to run it against that single client as opposed to all of it. If I check that that's run, we should see that case. Yeah, there we go. So there's one of my standard logical volumes. Now, what I'm going to do, I'm going to pause the video at this point, because the next stage was I was going to show you how we upgrade our VMs using NIM. So, but for the interest of time, what I think I'd rather do is skip on with the Tower stuff and the PowerVC stuff. If we've got time at the end, we can play this, the NIM side of things. So now we've installed it, now we've configured it. I'm going to upgrade that AIX, that VUG demo LPARs to the latest version of AIX using NIM, using the playbooks that we've created. But just for now, I'm going to skip back to the presentation. A couple of extra things in there that I think might be useful for you to look at. The main one I quite like in there is vaults. Vaults allows you to pass sensitive information, so you don't have to have plain passwords. You can encrypt those passwords, and you can use Vault to be able to control them. Okay, so not clicking. Tower. So Tower is licensable. So Tower isn't free. You can get an upstream version called AWX, I think it's called, which you can use for free. But the standard Tower version, you can get a demo license that allows you to configure up to 10 hosts, but it's a pay-for license. It gives us a UI and a RESTful REST API connection into Ansible. It's a very nice GUI. It allows automation. It allows us to be able to do push button deployments, and it's a very powerful tool. It works on the basis of projects. So we have projects that define that point to a certain location, and it picks up the playbooks within that location. You cannot create a playbook within Ansible Tower. You create the playbook and you call it from Ansible Tower. We can create sources such as manual or Git or Subversion, Mercurial, so there's various places. And I'll show you this with a live demo in a minute. It works on credentials. So how do you want me to communicate with certain inventories? So do you want to use a root user, like we have done in the examples I've just shown from the command line, or do you want to do something like the PowerVC credentials? We have the same the same concept of inventories. So how you saw the inventory working on the command line works pretty much exactly the same way from the GUI, and I'll show you the inventories. And then we have the core of it. So everything revolves around these templates. We want to run a job template against a set of clients. So it's an encapsulated playbook and various commands. It goes away and runs it, gives us a graphical display of what it's doing. It allows us to group templates together, and it allows us to repeat certain failed elements of a template should it occur. We need to run the template. We need the inventory, the credentials, and which project. That's all we need to be able to run against it. So let's log on to my Tower server if it's still up. Where's my cursor gone? Okay, so here's my Ansible Tower. Bigger. Okay, so here's my dashboard. It tells me what jobs have been run, whether they've been successful, what time of day they were, recently used templates, recently run jobs. I can look at my jobs individually. If I want to schedule jobs, I can see what schedules I've had. So I've got some inventory sync. So I go away and update my dynamic inventory for PowerVC every 10 minutes, I believe. And then we've got the information down here that I've been talking about. So we have credentials. So I've got a root user here. Obviously, we connect via SSH to the client, so I don't need a root password. It just has the fact that it's root. Obviously, if I want to use a different version, a different user ID, I can. If I look at my PowerVC one, it goes away and tells me the description, organization, what type it is, the URL of my PowerVC server, and what default project I want to use. If I look at my projects themselves, we can see here are a few projects I've defined. I've got my AIX one, I've got my rel one, I've got a general one. And what that does is it asks you for the base project's path of your project and where your playbooks are. So I said all my playbooks are in AIX playbooks. Okay, so it goes away and says, okay, well, I know that you want me to connect whatever user I gave you, and I want you to go and look in this directory and in this subdirectory and bring my playbooks. What that allows us to do, it allows us to create templates. As I said, templates are the core to what it is we're trying to run against our clients. So if I say, I want to create a standard template, let's call this one AIX_VUG. I give an inventory, so I'm going to run it against my PowerVC inventory. I'm going to select project AIX. What that then does goes and looks in that directory that I defined. It says these are the playbooks that you could use. Now remember, I can't define the playbooks within Tower itself. They're done outside of Tower. So there's that setup AIX one that I ran a minute ago. So let's say that I want to connect to that one, those clients as root. Obviously, it's using SSH, so I don't have to put any password in there. And then I'm going to, for this example, I'm going to limit it. I don't want it running against the thousands of VMs I've got. So I'm going to prompt at launch. And that's all I need to do. So hopefully, if I save that, and I launch it, it's going to launch that template for me. So because I asked it to prompt limit, it's come up with a limit prompt. I could have hard-coded this in, but because I want it to just run on VUG, I think that was the name of it, VUG demo. Let me check. I've got the right host name there. It's going away. It's giving me all the information about the details and the sign. It's telling me what it's limited to, which environment, which playbook it's going to run, the administrator it's going to run, and here we go. It's running that playbook that we just ran from the command line. Now, nothing should really change as much because we've already run that playbook against this client. It's recognized here the fact that only one change, and that was the fact that I asked it to install that file set again. So, okay. So we've created a very, very simple template there. However, what if we wanted to do orchestration? What if we wanted to do a more complex type of engagement using Ansible? Well, we can do a workflow template. What a workflow template does, let's just give this a sample name, workflow VUG. Give it an organization. So we've got our lab services. Which inventory do you want to run it against? Okay, we're going to say PowerVC inventory again. And that's it for now. We'll say that. What will happen, it will bring up the workflow visualizer, hopefully. Yep, so here we go, our workflow visualizer. So I'm going to click on Start. And what should happen, it says these are all the templates that you predefined. So what do you want to run against this client? What do you want to include in this workflow template? So let's start with gather facts, a nice simple one. And at the bottom, we're going to say run it always. So we'll select that. Then we can say, after that, we want to run something else. So let's say we want to run check date, a simple module that goes away and checks the date of our clients. But we want to run this when the previous template was successful. So we say successful. But we want to run something if it fails. We want to run a deployment if it fails. So let's say, what else have we got here, which is fairly simple? Show host name. For this one, we want to say only run on failure. So here we go. We've got a green line saying on success, a red line saying on failure. This one is basically going to run it every time. Let's save that. Now I could run it from here, which I'm going to do. If I click on, did I click on save? I think I did. Let me just do it just in case. And I click on launch. I think I might have clicked on that twice. Here we go. So here we see the green thing. The green pulsing light means it's running, and then it's going to run one of these two. If we go to, I think I missed it. I think it's moved on to the next one. If we go to jobs, we can see that it's running here. So we can click on it from the jobs main dashboard, or we can click on it from there. And here we can see now it's run that one, It's gone down a green light and it's run check date. So we can see this. We can look at the details of that template. So we can plug various templates together. Should we see? Yeah, it's come back with the date on all our clients that we listed in there. So a very useful tool. And that template is available to use again. So if we look down here, where do I put it? Here you go, workflow VUG. It shows me that it's run once and it's successful. We can launch it again. Should we want, we can delete it. We can copy it. So let's just launch it again. And there we go. If it will carry on, it will do that. We can schedule that as well. That workflow can be scheduled to run nightly, whenever we want, a bit like a cron job. Okay, so that's Ansible Tower. I'm sorry if I'm pushing through this quite quickly, but we've got quite a lot to cover, sorry, folks. Because the last thing I wanted to cover briefly was PowerVC. So I think best, Jyoti, if I just carry on and we stop for questions at the end rather than I take questions about Ansible now. Is that okay? Or
Yes, that's fine. Carry on.
Okay, so we've got 15 minutes, so I should be able to cover the updates in this. Again, if there's anything else you want to know, please email me or ping me on a Slack or Twitter or LinkedIn, and or Rich, and we'll get back to you. So we're on version 1.4.1 of PowerVC at the moment, and we've got a few improvements, a few enhancements that have come out of the last 8-9 months, and a few things that have been withdrawn. So just going to go through some of these. So we can do an active backup now, PowerVC, where even when operations are in progress. We can share images again across projects. We can view who is running what with each project. So when an operation occurs, we can see username if we're using users against this, or whether it's the system. We can initiate support groups. I'll cover that. I've got a few more slides on these, by the way, in a bit, so I just wanted to briefly cover them now. We can deploy virtual machines using existing boot and data volumes, and I'll explain why we'd want to do that in a bit. We can change availability priorities of a VM. We can pin machines using a soft and hard option. I'll discuss the difference in a minute. And we can also recall machines following a maintenance mode evacuation or an automatic restart move. We can recall them to their previous machine. We've got the technical preview for PureStore, which is the integrated driver from the command line. Infinidata is we can use a registered pluggable driver. Flex volume driver for PowerVC if we're using that within our OpenShift environment. We can use Flex volume driver, new versions out, and within OpenShift OCP version 4.3, we can use the CSI driver within PowerVC now, so our worker nodes, our nodes can provide back-end permanent storage for our containers. We've withdrawn PPC support for PowerVC, so we can still use Little Endian PPC64 or x86. Guest support for SLAS Big Engine and Ubuntu 14.04 has been withdrawn, and we've got new Cloud Init versions out there for SLAS RHEL 8 and RHEL 8.1, and I installed RHEL 8.2.1 the other day, and that works fine. So a few slides around this, sharing images. So in the past, if you had an image in one project, it was a little bit cumbersome to be able to move it to another one. We could export it, import it, we could manage a VM that was running it, or we could do things from the command line. Now we can just set the image as public, and then all the projects can see it. Very useful. We can see who is running what operation. So in this case, if I just look at my messages, I can see that these deploys were run by a user called Stowaway D, and in the past we haven't been able to see that. And obviously it defines which ones have been run by the system as well. Now, initiate port groups. I like this one. This is quite good. So when we create a storage connectivity group in PowerVC, we gave it various values, like it had to have a minimum of 2 BIOSes, or we had to see both fabrics from each BIOS. But it was probably problematic being able to specify which adapters we wanted to use, which initiator ports we wanted to use within that storage connectivity groups. We can do that now. So for example, in this single path storage connectivity group I created, I said I wanted to use one BIOS, but in that BIOS, I only wanted to use that fiber channel port to be able to provide storage for my back-end VMs. So obviously this isn't really a good example of how you do it, but I wanted to highlight the granularity that you could go down to. Now, the initiator port groups that you set cannot break the rules of the storage connectivity group. So if you said the storage connectivity group must have, say, a minimum of 2 VIOS servers, I couldn't say my initiator port group is only going to go have 1 VIOS server. So the parameters of the storage connectivity group take precedent. You can't break the storage connectivity group values, but very useful, I think. This one is to be able to deploy images, to be able to deploy VMs using existing VMs. Now, we've had this conversation numerous times with customers, and where the storage controllers, the storage providers aren't willing to give PowerVC control to be able to create clone VMs. So when you create a new VM within PowerVC, we use a backend clone to be able to take the image, clone it to a new storage, and we point that storage at the new LUN. What this does is allows us to create a VM and point it at an existing LUN. Now, we've always been able to do this in an ad hoc way, but now we can do it via the GUI. So the first thing we do is we create an image. So in this case, I'm creating a Core OS image. But instead of adding a volume like we'd normally do when we create an image, we leave it blank. We just say there is no image with volume. It lets us do this. So then when we go and deploy that image later, we add a volume to it. Now we add that volume that our storage provider has created. So they would have obviously had to have done the back-end work to clone that LUN from, say, another Core OS or another AIX server. But they've done that cloning. PowerVC hasn't done it. They've cloned it. They've presented it to us, and we can now see it. So we add that as additional volume. So it lets us be able to deploy a blank image onto an existing LUN. And this can be root VG and data VG. So again, I think a fairly useful tool. We can choose whether we pin a virtual machine to a host where it's currently running. So if we pin a server, it migrates back to that virtual machine when that host becomes available in an operating state again. Or if we've got licensing issues, if we've got restrictions about where we can move things, how we can move things, we can hard pin. So we don't have to, so we are able to restrict the movement during a remote restart, DRO, or an LPM. So again, that's something I think is pretty useful. We can migrate inactive VMs now. So not something we've been able to do in the past, but we can now use migration with inactive VMs. We can recall a VM. So if we place a host in maintenance mode or automatic remote restart, and that server becomes available, then we can say to this VM, to a host, automatically recall your VMs. So when we saw that listing in the inventory earlier, that's what this is talking about. It's saying that host should belong on me. That VM should belong on this host. So now I'm available. I'm going to go and get it back again. So, and we can specify that down to a host level. We can set availability priority. So just an example of where we can do that. Now, one key thing I wanted to mention here, most of these changes, I'd say 80% of these changes that have been made in latest versions have come through requests for enhancement, so the RFE program. If you've got an enhancement you want PowerVC to make, then please put an RFE in for it. It goes to show that these do get listened to, these do get read, and they do get incorporated. We're actually listening to how people are trying to use PowerVC and making sure that it's appropriate to our open stack strategy moving forward. Okay, so that's all I wanted to talk about. I realised I've been speaking now for nearly an hour and a half without pausing for breath, but I had quite a lot to get through. And as I said, I didn't show the NIM upgrade, but we would have run out of time, so I wanted to make sure we finished the PowerVC section. Okay, that's my presentation, Jyoti.
Thank you very much, Stu. Run through very, very quickly of all the Ansible and PowerVC updates. So thank you so much. It sounds like you will need a little bit of a break now. And in the background, Rich Jeffries, we mustn't forget him. He's been helping answer those questions that have popped into the chat window as well. So Rich, if you could just have a quick look and see if there's any remaining questions. And in the meantime, what I'm going to do is just tell people about what's coming up next.
Yeah, so a lot of the questions were about installing Python, which is a problem with AIX, but there are versions available from the from official RPMs for Linux Toolbox site, and there's some pre-compiled ones, but obviously they may not be supported by your environment. So if you can use the ones from the IBM site, then use that instead. There was one question about the PowerVC Flex Volume driver versus the PowerVC SCSI driver, CSI driver, sorry,
Okay.
which I couldn't answer.
See it, but
So from Kenneth asking, how do we choose between PowerVC Flex Volume driver and PowerVC CSI driver?
okay. So the CSI driver is the strategic way forward. It integrates with using the standard container storage interface. The Flex Volume driver is obviously specific to the PowerVC side of things. So there's no real right or wrong answer, but the CSI driver is the more strategic method forward. It's faster, and it's in the testing that I've done, it's more reliable as well.
Okay. All right. I'm just going to share some information with everyone. So hopefully you can see my browser screen. First of all, the PowerVC information is on this page under IBM support site, and you'll see information about what's coming up. So obviously today's session has been about Ansible and PowerVC, but coming up next on 10th of June is a session by Nigel Griffiths, and he'll be covering what's new from a whole host of different aspects of Power Systems and AIX and Linux. So the abstract tells you a little bit more about what he's going to be covering. And then in July, on the 15th of July, Stuart Cunliffe will be back again, and we're going to be talking about OpenShift 4.3. So the title and abstract for that will follow, and we're working on that. So watch out for those sessions coming up, and on this same page, if you scroll further down, you will be able to see past session replays and presentations. So these are all links to further down in the page where the information is about each session. That's one thing I wanted to mention, and I already posted some info about the YouTube channel and the playlist for these PowerVC replays. Again, I'll post a link into the chat window and with the details of the replay. But there is a whole host of other sessions that you may be interested in that playlist. And then tomorrow, Stu is back delivering a session on a different series. It's the Brunch and Learn series that IBM Systems UK and Ireland are running. And that he's going to be talking about delivering a cloud-like experience on-prem. That's 30 minutes bite-sized session, and it is part of the Systems Brunch and Learn series. And the sessions that are running, the other sessions that are running or have already run, are on this page in the LinkedIn post. Again, I shared the link with you. And the replays for that series is available on a playlist as well. Again, in the replay email I will send you, there will be details of this included. So that's it for what's coming up next. I'm going to stop sharing my screen and come back to Stu and Rich in case there are any more questions that have come up or any outstanding remaining ones that you need to address.
I think there's a few. I think we need to go through that list and see what we need. So I'll check with Rich, and
Okay.
Can we export that chat?
Yes, I'll capture them, and then perhaps between you two, if you provide me with a kind of Q&A, generalized Q&A, we can post that on with the replay as well, or after the event. That's fine. Thank you.
Yeah, there were lots of questions, mostly around the Python and also about where do we get the AIX modules from. So again, wherever possible, use the official IBM ones. There are some which are being developed by the community, and that's the whole idea with the Galaxy. You can create your own modules and share them out to the Galaxy community, and other people can use them. But obviously, if you want to make sure you have ones wherever possible from a good source.
Excellent. Thank you, Rich. Okay, I think we'll call it a day. I'm going to stop the recording, and we can stay on for a minute or two more after that. Thanks all for joining.